Hidden inside the world's warmest tropical regions grows a small brown fruit, simple on the outside, but unbelievably sweet within.
Before sapodilla becomes a creamy dessert or sweet topping, its story begins here, in humid tropical.
In the early hours of the morning, moisture gathers on waxy sapodilla leaves. This natural hydration cycle protects.
Sapodilla doesn't rush. A single fruit can take 6 to 8 months to fully mature.
Historically, sapodilla trees grew wild in the tropical forests of Central America. Indigenous communities valued. Through trade routes and migration, sapodilla traveled across oceans, eventually taking root in
Sapodilla remains a fruit deeply connected to the land and the people who care for it. Each fruit represents months of patient growth, and yet this is only the beginning. In the next chapter, we'll step inside a modern sapodilla processing facility, where
For sapodilla, sweetness begins in the soil. Farmers and agronomists regularly test the ground to protect both water supply and plant health. Most modern orchards use drip irrigation systems. Instead,
A sapodilla fruit grows slowly. From flower to maturity can take 6 to 8 months.
Ulysses. Pollination plays a vital role. Tiny insects transfer pollen between flowers, triggering fruit formation.
Modern orchards now integrate digital weather stations. These systems track humidity, rainfall, and temperature in real time.
sapodilla bruises easily, which is why harvesting is almost always done by hand. Workers twist the fruit gently.
In this stage, agriculture meets science. Every decision, from soil chemistry to irrigation engineering.
before the fruit even leaves the orchard, it is pre-graded. Larger fruit ripens slightly differently than small.
These crates are not solid. The perforated walls allow air to circulate, preventing trapped heat and moisture.
From the orchard, the fruit travels in temperature-controlled trucks. These vehicles don't freeze the fruit. Instead, inside the cabin, digital sensors constantly monitor temperature and humidity. If conditions shift even slightly, sapodilla bruises not only from impact unking, but also from micro-vibrations. Modern transport trucks use suspension seatings. After careful transport, the fruit finally reaches the processing facility. But the journey is not over. Even unloading is engineered. Soft belt conveyors reduce drop height and slow the fruit's movement, so there is no.
When sapodilla reaches the factory, it isn't fully ripe yet. And that's intentional.
The fruit is placed inside insulated ripening rooms. These rooms don't guess, they measure everything. To signal ripening, a tiny amount of ethylene gas is introduced. This is the same natural hormone the fruit produces on it.
Temperature is kept mild, usually between 20 and 25 degrees Celsius. Warmer conditions would rush the chemistry. Cooler temperatures would slow it too much. Powerful, yet carefully calibrated, fans keep the air moving. Without airflow, heat pockets could form, and each batch is sampled and tested. A Brix meter measures natural sugar content. A firmness machines but humans provide data, but human eyes add experience. Inspectors look for subtle cues, color change.
With sweetness locked in and texture now perfectly soft, the fruit is ready. The next phase will, before sapodilla can become puree, syrup, or dessert filling, it must first be made perfectly clean and food safe.
The first pass is a high-pressure rinse. Multiple nozzles spray purified water from every direction, loosening soil and debris from the skin.
After washing, the fruit passes through UV sanitation modules. Ultraviolet light damages the DNA of surface microbes.
Sapodilla skin is thin, so peeling must be precise. Automated peeling systems use sharpened stainless blades guided by pressure sensors.
Inside each fruit sit glossy black seeds. Automated separators gently split the fruit and remove the
At the end of this stage, the fruit is spotless, peeled, and ready. Every surface. Once the sapodilla has been washed, peeled, and prepared, the transformation begins.
The peeled fruit first enters industrial pulpers. Rotating blades and perforated screens gently break down the flesh.
Next, the puree passes through ultrafine mesh filters. This step removes tiny particles, creating a smooth.
To produce syrup and concentrate, the puree enters vacuum evaporators. Under reduced air pressure, water.
The next step is pasteurization, briefly heating the product to remove harmful microbes.
For frozen cubes and dessert bases, the puree is portioned and rapidly cooled inside blast freezers. Fast freezing forms tiny ice crystals. In another part of the facility, puree is blended into dessert bases. Automated paddles create controlled turbulence.
Finally, every batch is sampled in a laboratory. Technicians record sugar level, acidity,
This is where flavor becomes experience. Inside the dessert hall, carefully engineered machines
Every recipe begins with dosing. Automated feeders control the exact flow of puree and syrup into the mixing tanks. High shear mixers blend sapodilla puree with cream or stabilizers.
For ice cream, the mixture enters a continuous freezing barrel. As the walls chill the liquid, rotating blades scrape frozen crystals from the surface.
Elsewhere on the line, piston-style depositors portion custards and yogurt blends into cups and pastry shells.
Design matters. Some desserts feature layered textures, puree folded into cream, or cirrus ripped.
Shape consistency is important for packaging and presentation. Automated molds and cutters ensure every unit moves. Shape consistency is important for packaging and presentation. Automated molds and cutters ensure every unit moves.
The finished desserts then pass through cooling tunnels, allowing proteins and fats to stabilize. This
In another test, viscosity, or thickness, is measured using a rheometer. Texture consistency ensures that
Every batch receives a unique identification code, scanned at each stage of production. This creates a digital trace.
On the line itself, metal detectors and X-ray scanners act as the final protective barrier, ensuring no foreign objects find their way into the food supply.
Once every dessert passes quality testing, the final stage begins: packaging. This is more than wrapping and boxing.
in some products, oxygen is replaced with food-grade nitrogen gas before sealing. This modified atmosphere slows.
Tamper-evident seals provide visible security. Laser-etched batch codes ensure traceability, so every cup and carton.
Robotic palletizers group products into cartons and stack them with absolute precision. This repeatable accuracy.
The packaged desserts move into cold chain storage. Here, temperature is controlled to within a narrow range.
Smart sensors monitor every shipment, recording humidity, vibration, and temperature. If any value drifts out soon. From here, cold chain logistics connects continents, delivering desserts to cafes, supermarkets.
The final chapter of the journey begins here, inside chilled display cabinets at cafes, supermarkets, and bakeries.
In professional kitchens, portion scales and scoop systems ensure consistency, the same serving size. In professional kitchens, portion scales and scoop systems ensure consistency, the same serving size. Sustainability continues beyond the factory. Recyclable cartons, optimized transport loads. This is the story of Sapodilla. Guided by farmers, refined by engineers, protected by